Hello everyone, welcome back to the tutorials on Ansys Workbench. In today's session, we'll solve one more truss problem. So it's an exercise problem. For the 2-bar truss shown in the figure, determine the nodal displacement, reaction forces and elemental stress. So assume Young's modulus as 210 GPa, area is 600 mm square for each element. So in the given sketch, these two vertices are fixed and this pin joint is subjected to a load of 1000 kilonewton, as well as this is not fixed. It can able to move freely in the x direction. So let us solve this problem by using Ansys Workbench. Static structural, rename this as Truss 2, engineering data, edit the engineering data, Young's modulus so this is 2.1 E5 to 10 GPa. So go back to the project, right click on geometry, new space claim geometry. So click on y-axis, select line command, and till here press escape. Dimension 4 meter and height 3 meter. So this is 4 meter, the sense 4000 millimeter. Next from here to here 3 meters means 3000 millimeter. So click on view, top view. Okay, and sketch editing. So now define the cross section. In the problem, he has not mentioned anything about the cross section, but directly he has given the area 600 mm square for each element. So let us assume this as rectangular cross section. Go for prepare profiles, rectangle cross section, expand this beam profile, click on rectangle. So area is 600. Click on the screen. Repeat the same procedure for another element, rectangle, rectangle 2, area 600. Next, expand these curves. Next, click on line 1, assign this as rectangle 1. Click on the screen. Again select the another line, select rectangle 2, click on the screen. So now click on design 1, share topology, share. Now go back to the project workbench, right click on model, edit. So now the truss structure has imported for the analysis. So right click on the screen, view, click on top. So next, single geometry, cross sections are already defined. Directly go for mesh, right click, generate mesh. As it is a simple geometry, directly generate the mesh. Next, these two vertices are fixed. static structural, right click, insert, fixed support, select this vertex, press Ctrl, select this vertex, click apply. Next, static structural, right click, insert, displacement, select this vertex, so here it can move in the x direction freely. So apply, x direction free, and y is 0, z is 0. Okay. Next, again go for static structural, right click, insert, force, select the same vertex, apply, change this vector to component. So in the x direction, minus x direction, see the compass here, we are applying it in x direction, so it is minus 1000 kilonewton. So next, solution, right click, insert, deformation, total, right click, insert, beam tool, expand this, press Ctrl, select these two and delete this. Solution, right click, solve. Yeah, your solution is done. So click on total deformation. So this is the minimum deformation and this is the maximum deformation in mm, 20.996 mm. If you want to play the animation, you can play the animation. So this is how the deformation is happening in the truss structure. Pause this, click on direct stress. You can also play this animation. This is the maximum stress induced in the truss element. Pause this. If you want to see the reaction forces, go for insert, probe, force reaction. Click on force reaction. So it is asking at the fixed support. Click OK. Right click and evaluate all results. So at that position, this is the force reaction. If you want to generate the report, you can click on report preview. So your report is ready for further use. You can print this or you can share this. That's all for today's session. Thank you. See you in the next video.